Well, welcome to our lesson on solving radical equations and inequalities. We have a single learning target for this lesson, and that is for you to be able to solve radical equations and inequalities. And first of all, a radical equation or inequality is any equation that has a radical in it. So when we're solving the radical equations, our goal is to go ahead and isolate the radical. And once we have that radical isolated, we are going to raise each side of the equation to a power that will eliminate the radical. And that is done by making that exponent or that power equal to 1. Make sure to check your solutions in your original equations. As you will see in our examples that I'm going to show you, sometimes you're going to get what we call extraneous solutions. So let's go ahead and jump in and look at an example. In this example, we want to solve the square root of x plus 1 plus 2 equal to 4. So again, isolating this radical, we would subtract 2 from both sides. And once we have our square root, then we want to find a way to eliminate that. Now, one of the things you may remember, and I'll just show you this off to the side here, x plus 1, the square root of that, this means the exact same thing. Remember, the square root is really the 1/2 power. So these are equivalent expressions. This means exactly the same thing. Okay? So in order to get rid of that radical, what I really want to do is I want to raise this thing to some other exponent here. I need an exponent that will get rid of the 1/2. Well, remember, a power to a power, we multiply. So if I multiply that thing by the reciprocal of 2, these two, when you multiply, equal 1. So then we'll just have x plus 1 to the 1 power. So whatever your power is, take the reciprocal of that, and that's the power you will raise it to. Okay? So back to our problem, we're going to square both sides then. So whenever you have a square root, you square it. And that gets rid of your radical. So you have x plus 1 is equal to 4. Subtracting 1 from both sides, we get x equals 3. Let's plug that back into our original equation here on the right-hand side, and we get 3 plus 1 under the radical, which is 4. And 4, taking the square root of 4, that gives us 2, and 2 plus 2 is indeed equal to 4, so that checks out just fine. Here's another example. Let's look at this one. This one we have a radical on both sides, and so we can't really isolate our radical. We can't combine those because they're not multiplied or divided, but they are added and subtracted. So we're just going to go ahead and start off by squaring both sides. Now remember, when we square a binomial, on the left we just have a radical to square, and when we square it, it gets rid of the square root. But on the right hand side we have a binomial. So we have 3 minus the square root of x multiplied by 3 minus the square root of x. That's what it means to square something. So remember, your first terms are going to give you 9. Your outside term will give you minus 3 square roots of 2. Your inside will give you the same, minus 3 square roots of 2. And then your last terms here, minus times a minus is a plus. Whoops, this is an x, excuse me. These should be x's, so make sure to edit that. Minus square root of x times minus square root of x is plus the square root of x squared, which is just x. Now these two middle terms combine to give you minus 6 square roots of x. So here is what you end up getting when you square both sides. This one, the radical just drops. This one, our first terms gave us 9. Our middle term is minus 6 square roots of x. And our last terms were plus x. So now we have some terms that we can combine. We can subtract 9 from both sides, and we could subtract x from both sides. The x's drop out completely. The minus 9 adds with the minus 15 to give us a minus 24. Well, now we can divide both sides by negative 6, and that gives us a positive 4 is equal to the square root of x. And now we can go ahead and square both sides again, and we end up with x equals 16. Well, let's do our check now. Let's see if this is a valid solution. Our original equation we're going to plug in right here, and x is 16, so 16 minus 15 is going to give us a 1. On the right hand side, when we plug in 16, we get a 4 over here, and we get 3 minus 4, which is a negative 1. And positive 1 is not equal to negative 1, So this is not a valid solution. This is called an extraneous solution. So there is no solution on this one. Let's go ahead and try another example. This time they give us our radical in exponential form. So we have this to the 1/3 power. So again, we're going to try to isolate this thing first. So we could add 2 to both sides. So the 2 moves over to the right, and then we could divide by 3. And so now we have our radical isolated. Well, I need to raise this to a power to get rid of that 1/3. So raise it to the 3rd power. That's the reciprocal of 1/3. And whatever you do to one side, you must do to the other. So now these completely cancel out. On the right-hand side, 2 to the 3rd is 8, and 3 to the 3rd is 27. So you're going to have to remember your perfect cubes when you're dealing with some of these. Now I'm going to add 1 to both sides, but in order to add 1 to this, it really needs to be in the form of 27/27 so that I have like denominators. And so that gives me 35/27. And then when I divide by 5, remember dividing by 5 is the same thing as multiplying by 1/5. When I multiply by 1/5, my 5 cancels here and I get a 1, but I get a 7 in the numerator. So I end up with n being 7/27. Okay, let's go ahead and plug that in over on the right-hand side. We have our original equation, and I'm going to plug in 7/27 for n. Multiplying through, this is like 5 over 1, so I have 35/27 minus 1. Well, 1 is going to be 27/27, and 35/27 minus 27/27 is 8/27. And then we're going to go ahead and distribute our 3. The 3 will cancel with the 27, giving us 8 over 9. And that's to the 1. Oh, I did this backwards. Hang on a second. We got to do the exponent first, order of operations. And so taking our 1/3 power first. So the cubed root of 8 is 2, and the cubed root of 27 is 3. Then distributing our 3, we end up with a 2 minus 2, which is 0. And so we do have a valid solution on this one. So don't do what I did. I was ready to distribute that 3. We got to take our exponent first. And remember, the 1/3 power means the cubed root. Alrighty, inequalities. To solve our radical inequalities, we have a couple of steps to take. If the index or the power of the root is even, what we want to do is to identify any restrictions on our domain. Those are the values that would make our radical, underneath the radical, negative. Remember, that has to be a positive value or else we have complex solutions, and we're not going to deal with those. We want real solutions. Then we're going to go ahead and solve the inequality algebraically as we normally do. And then lastly, we're going to go ahead and test some values to check our solution. So let's go ahead and jump into one of these to see how this works. And the first thing we're going to do is to go ahead and see if there are values in our domain that we need to exclude. So under the radical, we have 4x minus 4, and that thing has to be greater than 0. It has to be positive. So we're going to set that greater than or equal to 0 and solve it. Adding 4 to both sides and dividing by 4, we find that our domain is restricted to anything greater than or equal to 1. So we can't have any values smaller than 1 because we'll get a negative under here. So we can only use values greater than or equal to 1. So now our second step is to go ahead and solve the inequality like we have done in the last slides. So we want to isolate that radical. So I'm going to subtract 2 from both sides. And then I'm going to square both sides. Okay, 4 squared is 16. Radical goes away. Add 4 to both sides. We get 4x is less than or equal to 20. Dividing by 4, we get x is less than or equal to 5. So here we have x must be greater than or equal to 1. But x must also be less than or equal to 5. So we only have a very small range of values that are going to work. Anything between or equal to 1 and 5. So let's test some values. Let's check something that's less than 1. Okay, let's check something that's in our range here. We're going to try 3 test values. One of them that's less than 1, one of them that is between 1 and 5, and one of them that's bigger than 5. So the ones that are outside this, less than 1 and bigger than 5, should give us wrong answers or extraneous solutions, and the one that's in between there should give us a valid solution. So here's what we would do. I'm just going to show this to you. I'm going to pull these out. You don't have to write these down. Just see if you can follow through with this. I'm going to plug in a 0. 0 is a value less than 1, so we should get a value that doesn't work, that gives us a false statement, or that doesn't work. When we plug that into our original equation right here, so this is the original equation, instead of x we have a 0, we get a negative value here. That's not a real number, so that doesn't work. So the value for anything less than 1 isn't working. Let's check one that is between 1 and 5. And I chose 2. So if we plug in 2 to our equation, our original equation, we get 8 minus 4, which is 4. The square root of 4 is 2, and 2 plus 2 is 4. So this works. 4 is less than or equal to 6. Remember, this has to be less than or equal to 6 when we work this out. And our inequality holds true. And lastly, let's try a value that's bigger than 5. I chose 7. When you choose 7, you get 28 minus 4, which is 24. And the square root of 24 is about 4.9. And then you add 2, you get about 6.9. This is not less than or equal to 6, so our left-hand side here is not true. And we find that the solutions that we found, anything between 1 and 5, are true. So a little reminder for you here. Remember, a principal square root is never negative. So any inequality that simplifies, when you get something like this, where it's less than or equal to c, and you have something over here that's negative, there's no solution. You can never have the square root of something being negative. So if you get a problem like that, just wanted to throw that out there for you, that those cannot happen, and we can't get negative values there. So that'll do it for this video. Thank goodness, because things are going crazy here. So we will see you next time.